Now it's out there, there is no dark matter, and the James Webb Telescope provides the proof. Unusual galaxies at cosmic dawn reveal that all our previous theories about the origin of the universe have been wrong. Scientists previously used dark matter to explain effects such as the formation of galaxies, but now there is clear evidence that these assumptions were wrong. Renowned scientists such as Michio Kaku explain that we must now completely change our cosmological worldview due to the many unusual observations made by the James Webb Telescope. A quote from Michio Kaku: "We have to rewrite all the textbooks about the beginning of the universe. It takes many billions of years to form a galaxy like our Milky Way with 100 billion stars, but the James Webb Telescope has found 6 galaxies that existed 500 million years after the Big Bang, and they are up to 10 times bigger than our Milky Way. That shouldn't exist." The James Webb Space Telescope marks an exciting turning point in astronomy and sheds a whole new light on our understanding of early galaxy evolution. Since the telescope was launched in the summer of 2022, one fantastic discovery has followed the next. The first image was already full to bursting with galaxies that are so old that they blow up our previous understanding of the universe. Michio Kaku puts it in a nutshell: the universe cannot be 13.8 billion years old if there were ready-made giant galaxies only 500 million years after the supposed Big Bang, or else galaxies develop in a completely different way than previously assumed. The images of the cosmic dawn have shaken the scientific community and aroused curiosity. We must finally find out how our universe really began. What have we overlooked so far? Where are our mistakes? And why are these galaxies proof that dark matter doesn't exist? An incredible twin of the Milky Way, can you imagine that? A galactic twin of our Earth existed almost 12 billion years ago. It's incredible because large and complex galaxies like ours could only have formed much later, but CEERS 2112 proves something completely different to scientists. The JWST brought to light that we were wrong. CEERS 2112 has a redshift of Z approximately equal to 3, and it is a barred spiral galaxy with a stellar mass of around 3.9 by 10 to the power of 9 solar masses. Barred structures have always been considered a sign of very developed and mature galaxies, according to our previous understanding. A galaxy can only show such a shape after an evolution of billions of years. But CEERS 2112 already existed 11.7 billion years ago, and we remember the Big Bang is said to have taken place 13.8 billion years ago. CEERS 2112 would therefore have been a real turbo-evolver. The discovery of CEERS 2112 raises completely new questions about galaxy evolution. If CEERS 2112 existed at such an early stage of the universe, we must now completely redefine our picture of the evolution of the universe. Galaxies like this force astronomers to completely rethink their models of galaxy evolution, and these discoveries inevitably offer completely new perspectives for the development of new theories. Until now, we assumed that the universe was a hot soup of gases and loose particles shortly after the Big Bang. Gradually, the universe cooled down, and the first atoms were formed. At this stage, the universe consisted mainly of hydrogen and helium. Under the influence of gravity, these gases began to condense into clouds. In these dense gas clouds, the pressure and temperature rose to such an extent that the conditions for nuclear fusion were reached in the cores of the first stars. These first stars were probably very massive and luminous and had a relatively short lifespan. Thanks to gravity, they formed the first groups, which were the nuclei of the first galaxies. The first massive stars often ended in supernova explosions, which released many heavier elements into the universe. These elements were crucial for the formation of subsequent generations of stars, which were not quite as bright and shone for much longer. Thanks to their significantly longer lifespan, more and more stars came together to form groups. Scientists imagine these first galaxies to be small and irregularly shaped, not at all like the large spiral and elliptical galaxies we see today. Over time, these early galaxies collided and merged with each other, creating larger and more complex galaxies. The formation of the diverse galaxy structure we observe in the universe today has been attributed by scientists to these merging processes. Galaxy mergers take millions of years, if not more. According to these theories, galaxies such as Sirius 2112 should already be 7 or 8 billion years old, and that would mean that they existed before the Big Bang. As you can imagine, the discovery of Sirius 2112 came as a shock to scientists. And even more incredibly, the JWST discovered much older, perfectly formed, and luminous galaxies in the cosmic dawn. Glass C12, the oldest galaxy of all, is a perfect example. Michio Kaku began by introducing us to the mysteries of the latest discovery. The JWST has discovered 6 galaxies that existed 300 million years after the Big Bang. The oldest of these is Glass C13, a galaxy that is a window into a time that stretches back almost to the origin of the universe. And once again, what our eyes see and what our measurements reveal challenges the ideas of how the first galaxies formed and evolved. Glass C13 is estimated to be around 13.5 billion years old. However, it must have taken at least a few hundred billion years to develop, which means that its age also extends beyond the Big Bang. Researchers have found further evidence of even older galaxies in the JWST data. Since these discoveries, the questions have been growing: how could a galaxy form so soon after the Big Bang? What processes led to their formation in a universe that was supposedly still in its infancy? Or did galaxies grow much faster? Dark matter, the solution to the mystery. Would you believe me if I told you that scientists have based the entire theory of galaxy formation on an assumption that has yet to be proven? Conventional cosmology assumes that dark matter plays a crucial role in the formation and evolution of galaxies. The equations only work out thanks to the invention of this matter. But now, the JWST proves that something about these equations could not have been right, and possibly the assumption of dark matter also turns out to be a dramatic mistake. Nobody can see dark matter, and nobody can measure it, but it's supposedly there. It's even said to make up 85% of the universe. Imagine that, scientists explain 85% of the cosmos with the existence of something that cannot be proven, measured, or seen. Then we can ask ourselves, how on earth did researchers come up with such an idea? This question is answered by effects that can be seen in the curvature of space-time. Dark matter makes itself felt there through its weight. It also allegedly exerts pressure on visible forms of matter. But this is still no proof of its existence. Scientists are often right with their theoretical assumptions. Black holes, for example, already existed in the mathematical equations of the general theory of relativity before any astronomer had ever seen a real black hole. This assumption was later confirmed, and similar examples abound in astronomy and other branches of science. However, mathematical assumptions such as the existence of dark matter are not always confirmed. We have to keep an open mind if we want to find out the truth, and the discoveries of the JWST are a current challenge to the world of researchers to rethink existing theories and come up with new models. Is M-theory right? The M-theory proves that our universe can also be explained without dark matter. It was proposed in 1985 by the Israeli physicist Mordechai Milgram. Modified Newtonian dynamics, or M for short, offers a radically different view of the gravitational forces in galaxies. Instead of pointing to the existence of an invisible and intangible dark matter, M modifies Newtonian laws of motion under very specific conditions. M proposes that the gravitational force in regions of very low acceleration, such as those found in the outer regions of galaxies, is stronger than predicted by the classical laws of physics. This fit could, for example, prove the rotation curves completely without dark matter. M has shown impressive agreement with observations in some cases. However, the theory also has limitations, especially in explaining phenomena on larger scales, such as the motion of galaxies in galaxy clusters and the cosmic microwave background radiation. These observations again fit well with the standard model of cosmology, which includes dark matter and dark energy. The JWST discoveries could provide new scope for theories such as M. If it now becomes increasingly clear that the conventional models of galaxy evolution and the role of dark matter need to be adapted, this could also mean that M will be further developed, or that scientists will come up with completely new approaches and present completely new, surprising theories. The fact is that astrophysics now has to break new ground, and we can look forward to seeing what emerges. Dark matter discovered in the Large Hadron Collider? Rumor has it that CERN researchers are also experimenting with dark matter, and these rumors are absolutely true. Scientists at the LHC have already tried to discover or create particles that could be candidates for dark matter. CERN is the European Organization for Nuclear Research and is known for its groundbreaking experiments in particle physics. In the Large Hadron Collider, the world's most powerful particle accelerator, protons are collided at almost the speed of light to study the fundamental building blocks of matter and forces. The protons are broken down into their building blocks by the collision, and researchers have already been able to identify dozens of much smaller particles. Theories such as supersymmetry have already postulated the existence of new particles that lie outside the standard model of particle physics. Their properties provide evidence that they could be part of dark matter. A key indicator of this is the absence of energy or momentum after a collision. Particles that are not directly detectable could therefore be potential dark matter particles. However, the existence of dark matter has not yet been fully proven. But science never sleeps. Astronomers working on the largest phenomena in the cosmos now have new tasks, and at the same time, scientists in Geneva are continuing their research into the world of the smallest particles. Science has been a discipline of experiments, assumptions, confirmations, and also failures and aberrations since ancient times. James Webb will revolutionize our view of the world, just as Galileo Galilei and Nicholas Copernicus provided to the world that the Earth revolves around the Sun and not the other way around. Subscribe now and never miss a new video.